Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be upon you all and welcome to the channel. In this video we will cover the creation of a dynamic array. So in the previous lecture we covered, or the previous lecture of that sub-series, we covered the theoretical portion of dynamic arrays, particularly their allocation within the computer's memory, and we have seen their disadvantages. Now we will see how to actually create a dynamic array. But before we begin, بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه ومن تبعهم بإحسان إلى يوم الدين وارض اللهم عنا معهم أجمعين اللهم آمين. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد. We begin in the name of Allah, the most merciful in this life and in the hereafter. And we thank Him for all of His blessings that He has bestowed upon us, for they are innumerable. And we pray that we follow in the footsteps of Prophet Muhammad, peace be upon him, and his fellow companions. Amen. We also ask for prayers and blessings to be bestowed upon Prophet Muhammad, peace be upon him, and his family, as they were bestowed upon Prophet Ibrahim, peace be upon him, and his family. So to recapitulate what we covered in the previous lecture quickly, so I will draw the heap because arrays are objects, thus they are stored in the heap. And here I will be using a one-dimensional array for this example. So let us say, for example, I have these numbers within an array. Now, if this was a static array, as in this size does not change, I will have the numbers as follows within a contiguous memory block, or contiguous memory blocks, to be more precise, like so. However, if I wish to create a dynamic array, the size will still be static, but you can program the size of the array to increase once a certain threshold has been reached. So that the initial capacity that we will start our dynamic array with will be 10. I use 10 because that is the same capacity used in a more effective form of dynamic arrays called array lists, which we will cover later on bi'ithnillah and God willing. So I can create this array as you see here, but with an initial capacity of 10 numbers or 10 integers. Thus I will have, so these are 4, I have 6 left. So 1, 2, 3, 4, 5, and 6. So as you recall, the default or the null values of an integer, the null value of an integer is 0, or the default number. So if you forget to provide a value for an integer, the compiler automatically assigns it the value of 0. So this new array will occupy the memory as follows. 5, 6, 7, 8, 9, 10. And we can increase the space between them for demonstrative purposes, like so. So as you can see, now we have 6 spaces in memory that are not used, but they are consuming memory, which renders this form of creating an array tedious, or I should say redundant, because you are not benefiting from these. Granted, you can design the dynamic array to accept to change the values here from 0 to whatever number you wish to add to it later. However, once the array is full and you wish to add again, you must set a static number to increase the capacity by. For example, you can program your dynamic array here. Once the array is full, you can program it to increase by doubling the number here. So from 10 numbers to 20 numbers. Thus, you will have 10 elements within an array and then another 10 completely empty, 0. So it is a complete waste of memory because you still have a static array even though it is referred to as a dynamic array, but arrays are normally static in length or size. As opposed to array lists, they can expand and shrink based on the needs of the user. So they consume memory in a more efficient manner. So dynamic arrays are completely inefficient. I would say from my perspective, the only reason you should learn dynamic arrays are either if the programming language you are using does not have an array list as an option, or simply to understand arrays with regards to memory allocation, memory management, as well as understanding the concepts of data structures. Because once we advance in the course, bi'idhnillah, and God willing, in the possibly far future, we will cover how to search for a particular element within an array and return its index, or see if an array is full or empty, and so on and so forth. So I feel that is, at least from my perspective, if you do not have the option to create an array list in your programming language, then it would be best to know how to program a dynamic array. But if you do have the option of an array list in your programming language, then I feel learning dynamic arrays would help simplify data structures for you. That is why I opted to add the dynamic arrays to the current playlist as opposed to leaving it for data structures. So now we have seen that it is a complete inefficient manner for creating an array. Now, what constitutes a dynamic array? In a dynamic array, you can expand its size, hence the term dynamic. In addition to that, you can also add elements. You can add elements to it, to the array, and normally addition occurs at the end of the array. So we can program the code to accept a new element at the end of the array, or at least at the end of the array that is actually being used or occupied with valid values, and as opposed to null values. There is another method that we should expect for a dynamic array. Let me center this before we continue. The other method, or the other form of addition, let us use a completely different color. This is known as insertion. Now, the reason they have two different names is because they are added at two different locations. Insertion inserts, normally, insertion inserts the element at a selected index. Or you can design it to insert the element at the first index, which is index 0, of course. So normally when you hear the term insertion, normally it refers to inserting an element at a particular index. But you can think of it as inserting an element at the beginning of the array. I will place it here then. Addition is always adding an element to the end of the array. It is always that way. If you wish to add an element to a particular index, that is known as insertion, not addition. I simply placed the arrow at the beginning here to specify that it has a specialized circumstance. In addition to that, to adding values, you can also delete a value. Now, normally when you delete with the particular value you do not approve of. You do not delete based on the border of the array, nor do you delete based on the index. You delete by specifying the particular element that you wish to delete. Deleting an particular element, like so. And that is what we will be covering for today. We will be covering how to add, how to insert, and how to delete, in addition to, of course, expanding the array dynamically. We will set a threshold where we can expand the array, but also we wish to shrink it to try and minimize the inefficient consumption of memory. Deleting an element, a particular element. Particular element. Let us expand this ever so slightly, like so, and there we go. So in addition to that, we will set a threshold that once is reached will expand the array, and we will also set a threshold that once is reached will shrink the array to avoid the inefficient consumption of memory. In my opinion, dynamic arrays are inefficient regardless, because you will still have empty places in the array that serve no purpose but to consume memory. Now let us design our dynamic array. So for this, we will create a new class. Oh, I forgot to delete this. I was preparing another lecture. So for this, we will create a new class. And in this class, we will create the various methods that we need to create an array, a dynamic array, I should say. What will I call this? Dynamic array. I will call it changeable array there. Just to change the cliches. Okay, so firstly what you will need are 3 instance variables or fields. You will need the size of the array, and this refers to the elements that are not null, that actually are part of the array, that serve the array. That is the size. We will not need to count the null values, the empty portions of the array. Those only serve to hold the place in memory until you add or insert. So we will need to cover the size. We will need to cover the initial capacity, which I will use as 10. As I mentioned, I use 10 because that is the number used in array lists. At least if I recall correctly, it was 10, or was it 7? I believe it was 10. But you can check if you create an array list yourself. You can check in the source code of the array list. And finally, we will need the actual array. We will create a simplistic integral array, an array of integers. And I will call it array. So these are the instance variables. You can create them as private if you would like. I will leave them as default or package private for convenience and simplicity. Then we will create the constructor so that you can define the so that you can use the array, of course. And here we will set this array equal to, here we will, so we declared the array, now we will initialize it. Well, not fully initialize it. This is still a preliminary form of declaration. But we will use the capacity here as the default size of the array. So as you can see, it is still a static array regardless, because you must specify the size. You must specify the size of any array you create. Whether it is a static array or a dynamic array, both are static. Now you can create another constructor if you would like to grant the user the capability of changing the capacity, where you can have, here you can ask the user to pass in the capacity they wish for, and here it will be this dot capacity is equal to the capacity passed here, and then you add this line. So for example, if the user does not want the initial capacity of the dynamic array to be 10, if the user wishes for it to be 5, for example, they can use this constructor, pass 5 here as an argument, and then the value here will change from 10 to 5, because remember, with assignment, the associativity is from right to left, not from left to right. So firstly, 5 is placed here, then it is assigned to this. If it was from left to right, then 10 would be equal to the argument passed. Then of course we will set the size of the array to the capacity that the user has set. So now we have finished the creation of the array. So let us test this quickly. Changeable array, I'll call it C, is equal to new. So as you can see, we do not have any errors. I will call this C1, and using the Zahi way, I will create C2, but with an initial capacity of 7. Then I will print both capacities, C1.capacity and C2.capacity. This should be 10, this should be 7. And there you have it. So now the user already has robustness and flexibility when creating the array. So from here onwards, we will use the initial capacity, so I will delete these. Now remember, we need an addition, we need to add numbers, or insert numbers, either or. We need to delete numbers or elements of the array. We also need to expand the array size dynamically and shrink it dynamically based on a threshold that you can designate. For this threshold, I will use either, well, actually, there is no need to speak of it now. I will show you that way I do not confuse you accidentally. especially since English is not my first language. Okay. Now let us continue with the method, the addition method. So public void, because it will not return anything, addition. So I should have specified here adding a particular element. Like so. I will not need the n. Adding a particular element. You will see why I say particular in a moment. Now I wish to add number 5 to this array, just as an example. So how would I add 5? Firstly, I need to specify that I need this number to be an element in this array. How would I do that? By passing it as a parameter here or as an argument. Normally people refer to elements created within a dynamic array as data. Normally. So you would see that when we start creating linked lists as well. So how would I create this data? Simply, it would be array size. Remember size. So if you have 4 elements already within the array, then the size is 4, even if the full size is 10. But the ones being used are actually 4. So that is the size. So these do not count as part of the size. These do, however. So array.size is equal to data. That is simply it. What does that mean? I wish to add the data at index size. For example, here we have 1, 2, 3, 4 elements. So the size here is 4. So this will be 4. But we have a problem. The index cannot be 4 because we start with 0 when counting the index. So this will be 0, 1, 2, 3. So how do we add an element at the end of the array? By using index 4 here. This is index 3, this is index 4, where the 0 is, but we simply add the actual value to it here. So basically what we are doing is placing this into here like so, and removing the 0. Like that. So that is why you put size, because remember, size or length, the index of the last element is the size or length of the array minus 1. So even though these are 4 elements, the index ends with 3. So if you wish to add after the end of the array, you will use the actual length or the actual size of the array, which is 4. Then, and this is an important step, you need to increment the size by 1 only. Why is that? Because when you add this number here, so remember these are the actual, these constitute the actual array. So the size here is actually 4. This does not count. Index 4 does not count. So when you add the 5 here, it still does not count. Why? Because the size is set to 4. But when you increment it by 1, the size increases from 4 to 5. So now it includes the newly added element. through this incrementation. Now, of course, this also applies when you wish to create the array from the beginning, because we will not design the dynamic array as we normally design a regular array or a static array. Initially, we will begin with 0, all zeros, and then we will start adding the array one by one. So I will leave this diagram here for now. Once we will actually start creating the array here, I will return to Paint and draw a new diagram, and then we will start adding and removing elements in a stepwise manner, so that hopefully it is understandable for you. So now we have created the addition. Okay, let us create the insertion now, where you choose to insert the element of your choice. This is also void because it will not return anything. Now remember, the term insertion could also refer to as inserting the element at the beginning of the array, but I will leave it defined as such because normally when you see the algorithm, and I will explain what algorithms are in a separate video bi'idhnillah and God willing. I have a playlist dedicated to general topics pertaining to computational science, such as the definition of artifacts, semantic versioning, and so on and so forth. What was it? Algorithms will be a part of that as well, bi'idhnillah and God willing. So normally when you see the code for insertion, it is normally placing a particular element that you define at a particular index you define. I simply placed it here just to remind you that it is different from addition. Insertion is at a particular location that you designate. Addition is always at the end. So, because in insertion you need a specified location, so you need the index at which you need to place the data or the element. You can call this element if you want. Maybe I should use element for simplicity. I simply wanted to use data in case you are perusing other content. You most likely will see the term data used often. But I will use element simply to remind you that we are using elements of an array. So how would I iterate through an array to find the particular index I am searching for, then placing that element at that index? To iterate through the array so that I can search for the particular index, I will need a for loop. If you iterate through an array for searching, for example, or locating or identifying a particular index, without thinking, you will use a for loop immediately. So it will be int I is equal to size, the end of the array. So we'll start at the end of the array. I will be greater than index. So this will be our starting point, the end of the array. And the ending point will be the index you designate. So for example, if you decide to insert element 6 at the beginning of the array here, you will start from here and then iterate through the array until you reach index 0, because you wish to insert this here. Now here is the trick. Oh, I forgot to increment I plus plus. Now, if I wish to insert 6 at index 0, that means I must change this index to 1, this index to 2, this index to 3, and this index to 4, which means that these elements will shift one spot to the right to accommodate the insertion of this new element, whether it is at the beginning of the array or otherwise. So for example, if I wish to add 6 where 2 is at index 1 currently, so I will have to shift all of these and place 6 here, like so. That is what I will need to do. So in order to shift the elements to accommodate for this insertion, this is the following code that you will be able to use. I is equal to array I minus 1. We will explain this once we actually create an array and then start explaining what happens diagrammatically. I feel with the diagram it will be much clearer than using the debugger, because the debugger does not represent it visually, since I feel I learn easily with a visual representation. That is the approach I will use with you as well. Hopefully it is effective. And I made a mistake here. This should be decrement. When you are iterating in a descending order from highest to lowest, you decrement. But if you are going from 0, for example, to highest, then you increment. After that, so this shifts the elements of the array to the right. Once it has been shifted, so what if I choose to insert 6 here, for example, the for loop that I showed you shifts. But this is still an empty spot, so I need to place this here. So what is the code for that? Here we will simply say array, the instance variable array, that is, at the index that you chose, which is now empty and ready to accept the inserted element, will now contain this element, like so. So now you have assigned the value at this particular index within this array. And of course, the same with addition, so that you factor in the new element that has been added. You increment the size by 1. That is perfect. Then we have deletion, to delete a number or an element, I should say, because you may choose to create an array of strings or an array of object student or object cat or whichever object you wish to design, or objects in general as the superclass object. So here, of course, you will pass in the element that you wish to delete. So here, for example, I chose to delete element 4. That means I will pass 4 here as an argument. Again, here I am searching for a particular element, which means that I will iterate through the entire array, trying to locate that element and designate it for deletion. So if I am iterating through an array, I will need a for loop. But here I will start from beginning to end. So it will be equal to 0. I forgot the I. There we go. And then I is less than size. Size here is the same as array.length. It is exactly the same, which means that it will always be less than, not less than or equal to, because the index of the last element is the length of the array minus 1, to avoid any exceptions, at least until you learn how to handle or overcome or catch exceptions, which we will come to at the end of this beginner level bi'idhnillah, and God willing. Now this will be slightly complex compared to addition and insertion. Firstly, so this will iterate through the entire array searching for this element. what would the program execute once that element has been located? So if array at a particular index is equal to element, so when the element is actually found, if it is not found, it will not execute the if statement. Once it finishes iterating fully, it will exit and nothing will happen. So this if guarantees that once if the element is located at a particular index within the array, it will then be designated for deletion. And this is where it becomes more complex. Even though this is a one-dimensional array, we mentioned in a previous lecture regarding the iterative process of a multi-dimensional array that the number of for loops matches the number of dimensions within an array, but we mentioned that there are exceptions, especially with jagged arrays. This is another exception. Here we will use another nested for loop, and this for loop is needed for a particular task. This is to iterate and locate the element. But once it has been located, what we need to do is simply remove it from the equation like so, and then push everything here like that. That is the purpose of this inner for loop. After the element has been identified, it needs to be eliminated, and then everything needs to shift to the left. So in addition or not addition, sorry, because this is added at the end of the array. For insertion, everything needs to shift to the right. For deletion, everything needs to shift to the left. So this is how you can shift the elements to the left. Int j, because this is an inner for loop, is equal to 0, and we covered the conventions for nomenclature of indices or indexes for outer and inner for loops. J less than size minus I minus 1. And it is best if I wrap these within parentheses to avoid any errors. Again, this is easier to understand once we view it diagrammatically, which will happen shortly bi'idhnillah and God willing, once we actually create the array together. J++, because we are moving from beginning to end, so we need to keep incrementing until and we need to shift as well, and so on and so forth. So what we do here is I plus j, like so, is equal to array I plus j plus 1, and this is where the shift occurs. Then this also continues the shift, size minus 1. Sorry, this is the deletion itself. This is the shifting. This shifts everything to the left. Is equal to 0. I placed this as 0 because remember, in an integer, for integers, the default value or the null value is 0. If this was an object, an array of objects such as string, for example, then you would put this as null. So this is the null value section to shift elements to the left. This is to delete element. I should say remaining elements here. So this is 0 because This is 0 because this is the null value since I created an array of integers. If this was a different array, simply place the null value. So if this was Boolean, for example, Boolean array, you would put false here. And so on and so forth. So this is shifting the remaining null values to the left once this has been deleted. Okay. Then, since I have a loop here, so for example, if the element I wish to delete is at index 2, and the size is 4 or 5, there is no need to continue iterating because it is redundant. So after this has been accomplished, after the deletion has been accomplished and the shifting, I will simply break from the for loop. Let me just check to see. This is... oh yeah, I should put it before the if ends, like so. Yeah. Because remember, you can break out of a conditional statement provided that it is nested within a loop. If you wish to break out of a conditional statement that is not present in a loop, you use the return keyword, which we have covered in a previous lecture. The break and return, or rather interruptions of a conditional statement and interruptions of loops, or conditional statements within loops. So that is perfect. Now this is for the class, so let me create a space here so I do not confuse myself. Because this is a class, this means it is an object. So how would I print the elements of this object? Because I cannot access the array traditionally. So I will need to use the Tostring method, if you recall, and we have discussed it previously. But because it is provided by the object class, it is best if you use the override annotation, and do not worry, we will cover annotations, but most likely in the far future. Why am I bothering myself when I have the Zahi way? Generate Tostring. Let us see what it yields. So override. No, actually, I do not want. I do not want that. I can use this, however. And remember, the Tostring method has a return value, and as we have discussed in its lecture. So I will just test this quickly to see how this looks like, and if I need to redesign it. So c.add 1, sorry, addition 1, and then print c. Originally you were supposed to type c.toString, but now the name of the object suffices. You do not need to use toString, as we mentioned before. So let us see how this looks. Okay, so there seems to be confusion here with this. Okay, so I do not need this then. This is also a good introduction to the Tostring method within the arrays class, not the arrays. There is a difference. And as you can see, arrays is a member of the Java collections framework. What did I click? Nothing opened. Anyways, okay. So arrays.toString, and you put the name of the array, converts your array to a string. This is, remember, the toString method transforms an object to a string. Hence the name toString. You simply add the name of your array here. Just remember this is a static method, so you need to call it using arrays.toString and then add the name of the array like so, which is this one, of course. So I will format it like so. This should be good. Or possibly we do not even need this. Yeah, I think this would suffice. This is formatted nicely by itself. Okay. Now we have an issue. So as you can see here, our dynamic array is not set to expand and shrink dynamically. So when we add elements until the full capacity is reached, it will not accept any more elements. And thus it will not shrink because we did not program it to shrink either. So we need to program it to expand once a certain threshold is reached, but also to shrink when a certain threshold is reached to avoid the inefficient consumption of memory. So what we will need to do is create an expansion and shrinkage method. I will create the expansion method here so that I can use it in addition and insertion, because those add elements to the array regardless of the nature of the addition. Thus they will need to use that expansion method. So normally, if you recall from the method hiding lecture, if you will create a method or use a method within another method exclusively, it is best to set it as private. Now for this method, we will create a new capacity which will accommodate for the expansion. Normally, the new capacity involves the old capacity multiplied by 2. However, you can customize that number as you see fit. But I feel multiplied by 2 is somewhat reasonable, considering that a user may enter a large number here. So 2 would minimize the expansion. And just to avoid any errors, should a user enter an incorrect format accidentally, such as a double that can be converted implicitly, you can cast the number like so, just to avoid any errors. But to avoid confusing you with the multitude of brackets, I will not cast it, but you can, or I will leave it here. Yeah, as you can see it here. Okay. Now here is why this is the dynamic arrays are inefficient. Traditionally, or technically speaking, you do not expand the array. You actually create a new array that is larger than the old array, and then copy the old array into the much larger new array. So it is rather annoying in that aspect, unfortunately, which is why I never recommend using a dynamic array. But I feel it is important for you to understand and visualize the concepts pertaining to data structures. From my humble perspective, of course, people may disagree with me, that is their prerogative. So what happens is, so this is a capacity of 10. I will create a capacity of 20. So 1 here. 1, 2, 3, or maybe 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we'll say 13 then. You copy these values, place them here, and then you keep adding to it. So just to avoid this hectic appearance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when this is full, you create a new array. Let me just adjust this. So let us pretend that these are 5, 6, 7, 8, 9, 10. You know what? I will add them, because the purpose of these lectures are to ensure that you understand, regardless of the shortcomings of teaching through a YouTube channel or teaching online without actually interacting with the student. So I do not care how long the lecture takes, as long as I achieve my goal. So once this is full, this method that we are creating will then create a new array that is much larger, but here of course we set it multiplied by 2, so this should be 20 instead of 13. Then it will copy the old array and place it into the new array. And once this is full, it will multiply 20 by 2, so it will create a new array of 40, then copy the old array into that new array, and so on and so forth. It is incredibly annoying and tedious, which is why no one uses dynamic arrays. Okay, so firstly we need to create the new array. So we created the new capacity, which is the old one multiplied by 2 to grow the size. Then we actually need to create the new array, is equal to new int with the new capacity. So this new array will contain 20 memory blocks, still empty of course, or still 0, until we copy the old array into the new array. So how do we copy? Well, firstly, you need to iterate through each element of the array, copy them and paste them into the new array. Or I should not say paste, but copy them and then place them into the new array. So iterate here, place it here, then iterate here, place it here, and so on and so forth. So if you will iterate, yes, you have answered correctly, or you have finished my sentence for me. If you did so, I congratulate you. You will need a for loop. And I less than size, of course, or array.length, and I plus plus. Here you will say new array at index I is equal to array at index I. So what does that tell the compiler? The element at this particular index through the iteration from 0 to 3, of course, in this array, place it at the exact same index, but in this new array. So this is copying the old array into the new array. That is basically what this achieves. Then after that, we will set the capacity to the new capacity, and then we will set the old array to the new array. So basically we take this, place it here, because remember, these are not instance variables. These are So firstly, we need to copy these into these variables temporarily to increase them. Then we assign the newly increased array or expanded array to the old values. You can set capacity equal capacity multiplied by 2, of course, but I thought this would be a neater approach so that you can understand the operational flow of this method. So you expand the capacity by 2, then you create a new array with that new capacity, copy the array into the new array, then place the new capacity into the instance variable, and the new array into the instance array variable or object. So let us use it in the addition here before we move on to the shrinkage. So before this portion, what we will do is let us set the threshold now. If the size or the length of the array is greater than or equal to the capacity, of course it will never be greater than, but it is simply to cover any errors, because if you set it to equal to, that means if it is less than, it will also trigger it. So we must define it as greater than or equal to. So that is our threshold. Use the expansion method. Basically what this indicates is that once the array has been fully occupied, expand it into a new array if the user, of course, wishes to add a new element. If the user wants to use the full 10 and that is it, do not expand. Hence the greater than. This accommodates for the addition should the user wish to add beyond the initial capacity of the array. Now for the deletion. As one expands, one needs to shrink or contract depending on the context. But I feel shrinkage here will be a more auspicious vernacular. So this is much easier to write because you simply will copy all of this, paste it here, but change multiply to divide. That way you shrink. And I feel divide by 2 is sufficient, at least for demonstrative purposes. Now we have successfully and thankfully created a dynamic array. Now let us test this. So what I will do here now is delete all of this, and I will create so instead of using 10, I will actually use the constructor to set it to 5, just so that it is easier for me to explain. And that way I do not waste your time, because it will become rather tedious to watch this lecture. So I feel it is best if we use this. Actually, before we cover the diagrammatical approach, there are 2 important topics I would like to discuss in this video here. This, if you highlight here, it says manual array copy. There is a much better method for which you can copy arrays with, and that is known as the array copy method here. Replace with system.array copy. So what I will do is I will replace it simply to show you what happens. This and this, like so. And I will, okay, maybe I can separate it like that. So if the size is greater than or equal to 0, start copying the array. You will call it using the system class. that we have been using to print print variables. And then you will call the array copy method using the name of the class, so that automatically informs you that it is a static method. But you can also cheat by looking at the italicized format. If you are using IntelliJ, I honestly do not remember what Eclipse does, and I do not know what NetBeans does. IntelliJ italicizes static methods like so, just in case you forget what a static method is. So what happens is, or rather the arguments needed for the array copy method, firstly, you set the old array that you wish to copy. Then you set the source position. From where do you want to start copying? From the first index, from the first element or the 0th index. So this is index 0. So start copying the old array from its beginning. If you set it to 1, it will copy from the second element or the first index. So I wish to copy from the beginning of the array. Where do you want to copy the old array? Into the new array. Where do you wish to start the new array from? Index 0. So this belongs to this, and this belongs to this. I wish to copy the elements of the array, all the elements of the array starting from 0 and placing it in the new array starting from 0. You can place the new element starting from index 2, for example, as you wish, and then place the size of the old array so that the new array can also accommodate the new size. And that is it, really. That is the array copy method. So I will leave the manual, where is it? Shrinkage, yeah. I will leave the manual copy. Manual array copy. And I will also leave, perhaps I should put this, put it here and then label this as array copy method here. So that is firstly what I wanted to show you. Another portion that I wanted to discuss, the toString method. So this is if you are using arrays.toString method. There is another style you can use, which I will show you. And the reason I will show this to you is to remind you that if you are designing an output of the array, you can customize it using the string builder class. String, oh yeah, I forgot it is a camel case or uppercase, I forget. I will call it string is equal to new string builder. You can also use the string class, but I wanted to use this lecture to show you the string builder class in case I do not create a lecture for it. Then I will iterate through the array to print the elements. So it will be int I is equal to 0, I is less than the capacity. This, of course, is used if you wish to print everything, even the null values. Oh, my back. I am too old for this. Okay. Then here, you will use the append method to start appending or attaching strings at the end of the string. So firstly, I will print the array like so. Append basically means attaching at the end. So for example, here I will have welcome to. I wish to add an extra word at the end, so I wish to append an extra word to the end here. What I did now is known as appending. So here what we are basically do is appending each element of the array at the end of the previous one, and then appending after the element, we will append it with a comma like so. And then simply return the string. Now I will show you why I am showing this to you, because, and of course we need to use the Tostring method here. I will show you why I am revealing this to you now, because this was a part of my interview and I could not answer it. So I would like for you to avoid that. If you are having an interview, they might ask you to print an array. I will show you what the problem is here. So I will just add 3 values quickly, and do not worry, we will explain in just a moment. But I wish to show you a problem with this Tostring method. Thankfully, it was avoided with this, so you can use this if you would like. But just in case, because in my interview, I completely forgot about that, to be quite honest. Because I did not know what to expect, since I did not expect a programmatic interview. Because it was part of an internship. It is not truly an internship, but similar to it. C. So you see here what the issue is. It still adds that extra comma and space. So I wanted to show this to you so that I can show you how to remove that extra comma and space once you reach the end of your array. A simple if statement would resolve it for you quickly. If the string dot to string, because you are using string builder, so you have to use toString, because the string even though the string builder is a string, it is still an object that needs to be converted to a string. Dot equals, and I forgot this. So remember, because I am using string, I use equals. I do not use this. This will associate it with a memory address. This will actually check the content. So if this string is not empty, so it actually has values, then print it like so. String is equal to new string builder. And the beauty about the string builder class is that you can set how you wish to design it within the constructor, or you can use append here. So this is a good opportunity to show you the string builder class in a bit more depth than we have discussed in previous times. So I will place them within curly braces, string dot substring, and this functions exactly as the substring method in the string class, or maybe not exactly, but as the string method. So I will use the start and the end instead of just the start, because I wish to cut off at a certain, begin my cutoff point or my threshold at a certain index and end it at a certain index. So what is the portion that I wish to keep? I wish to keep the beginning, so index 0, and my threshold will be the comma and the space. So these are 2 characters that occupy the array, or I should not say the array, the string. So it will be string dot length, and we covered the dot length method in strings before, -2. Why -2? I am cutting off this and this. Plus, and then I will add the curly brace again. So if the string here that I have been appending is not empty, if it has values, then redesign the string into this. So this cutoff point removes the extra comma and the extra space. Y minus 2, y string length minus 2, because if the printed string is 10 characters, that means the 9th and the 10th character are these two. So I remove those last two. Else, if the array is empty, I wish to customize the output to appear appealing. New string builder. And I will say array is empty. You can, of course, customize an array is empty method, but I wish to keep that for the data structural portion instead of the beginner level here. So let us print this again, and hopefully the comma, oh, it has disappeared, and it surrounded the array with the curly braces. What if I wish to test and see if the else statement is functional? Because this else codes for if the string is empty. So if nothing is in the array. Oh, it printed this instead. Okay. Okay, so what about... Oh yeah, I just realized because it keeps appending it here. So yeah, this does not do anything. Oh, okay, so I will need to check this then. Oh, I know why this is an issue. Because I'm using string builder instead of string. Yeah, never mind. So I will, yeah, I will avoid using this because this functions better if you are using string. The string class, that is, not the string builder class. Okay, so I will remove this from compilation and return this because it is much easier and simpler. Oh, I do not need this actually. Oh, I do need this, but as a comment. Yeah. And this is string builder class, like so. There, perfect. This is perfect. Okay. Now for the diagrammatical approach. I might as well show you the string class. String class for the sake of comprehension. And this seems to belong to... Oh yeah, it needs a return statement. That is why it is providing an error. So we will say string is equal to empty, and we can add to it later. Then I will copy this, paste it here, and here is where we can use the concatenation operator as what were they called again? Compound assignment operator. So we covered compound assignment operators in their respective lectures. However, plus equal can be used for concatenation in addition to, well, addition. So you will say plus equal, and then it would be array I, like so. Oh yeah, plus comma space, like so. So let us, oh yeah, I need to return it, return string. So let us test this quickly just to see what we have. So we still have the same issue. Now let us rectify it with this. So you will see that, and this should be string is equal to array I oh yeah I lost my train of thought. Yeah, let us avoid using the string class because I am slightly confused at the moment, so we'll avoid using it. And could be because I have been recording for a while today, so my mental faculties are not functioning at their full limit. But I can post the code later on in the comments below. I think I will end the lecture here for today and continue in a separate lecture because I feel I am a bit dehydrated and tired, so I apologize for that. But I will record bi'ithnillah and God willing another lecture to follow this one where we discuss how to use these methods and explain it diagrammatically. I hope this lecture was helpful and beneficial to you all. Enjoy the rest of your day, everyone. Be safe, take care, and peace be upon you all. والسلام عليكم ورحمة الله وبركاته. اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد.